Mechanics, kinematics, jet and missile. We have a jet which is flying on a height h above the ground with a constant velocity u. When this jet reach point exactly above the missile, we shot this missile, and now this missile can fly with the same velocity u, but in a direction exactly pointing to this jet. So we need to find what happened in the future when the jet is going this way and the missile going like this, because these two velocities, they are equal to each other. It means that this missile never reach our jet, but we have to find what is final distance between them. What is this final distance d? So that's the question. Okay, if we try to solve this problem in our regular system, like this one, probably this problem would be very difficult. But we can choose other frame of reference, which is consists of such things. Suppose that one coordinate will be distance between jet and missile in x direction, so that's x. Other coordinate will be distance between missile and jet in y coordinate, and let's choose other coordinate which is distance between jet and missile, so that will be s. And now we can write how do they change, like infinitesimally for delta t. We can write this expression that dx equal, let's connect our points. This direction, it's a tangent to our curve, so it means that if this is angle theta, we can write that dx equal this is same theta, dx equal u multiplied by cosine theta multiplied by dt. This is how this jet increasing this distance x, and we need to subtract, oh, I'm sorry, we have dx equal so we have dx equal velocity u multiplied by delta t. This is how this dx increase for time delta t by a jet, and missile has a projection on x direction for this velocity, which is u multiplied by cosine alpha and multiplied by delta t. So this is how dx changing during time delta t. Let's write the same thing for dy. That will be jet is not changing anything, and the missile changing negative u multiplied by sine theta delta t. And let's see what happened to ds. ds now changing by jet by projection of this velocity to this direction, which is u multiplied by cosine theta dt, and we have to subtract how is our missile reducing this distance, which is just u multiplied by delta t. If we look for these three equations, we can see that this equation not helpful. We can eliminate this. But if we look at this and this equation, we see that dx exactly equal negative ds. So if we add them, they just cancel each other. So we have dx plus ds equals 0. And we can integrate this expression. So that will be integral x is going from 0 to final distance d. Final distance d from delta x, plus s is going from h to same final distance d, ds, and that's equal 0. So this integral equal d, and this integral equal d minus h, which is 0. And now we see that the final distance will be h over 2. So that's the solution for this problem. Let's do this problem a little bit more complicated. Now we suppose that this velocity not u, but missile has velocity v, which is greater than u. So it means that this missile eventually will meet this jet. And the question is, we need to find what is time for this travel. How long time it will take for missile to meet this jet. Let's write the same equations. So we have now dx equal, again we have u multiplied by dt, and now we need to subtract not u but v multiplied by cosine theta dt, and ds now it's equal projection for jet velocity on direction s, which is u cosine theta dt, and we need to subtract this how is our missile reduce this distance, which is v multiplied by dt. So we have these two equations. Now, good idea to eliminate cosine, because it's not constant. So for that we can multiply this part by u multiplied by u, and this part multiplied by v. And after that we can add these two equations. In that case, this part and this part, they just cancel each other, and we have this expression u dx plus v ds, that's equal u square minus v square multiplied by dt. And we have simple equation which can be integrated. Again, we know what are limits. We have u multiplied by x, which is going from 0 to 0 dx, initial meaning is 0 and final is 0. They will meet each other. And we have v multiplied by initial is h distance and final is 0 ds. And that's equal to u square minus v square multiplied by total time t. So this part is 0, this part is negative v h, and that's equal u square minus v square t. And finally total time equal v square minus u square over v h. So this is solution for our problem. And of course this problem can be solved for any initial condition. I mean that if we take any position for jet on the left or on the right and start this missile in any time, we can find this time as a function of this initial distance from origin. We can use the same equations and the solution will be the same. The answer will be a little bit different. So this is demonstration how to use correct frame of reference to solve problem in kinematics.